Well, thank you for the opportunity to talk about this project. Just a couple words about myself and the company I work for. I'm an enterprise architect at NAV. I've been kind of a troublemaker in the industry, let's say that, for many years. And I specialize in building service-oriented architectures. That's generally the type of work that I've been doing pretty much since 1998, when I started to use web methods as an API platform for B2B applications. I tend to like this space, and I'm not looking at going much further outside that space. And the schema architecture is a project that I feel is very important. And I started actually what you'll see today. I designed it in 2009 and published an article on InfoQ. I built a product in 2015 when I was in Sydney. Tried to market it to different companies, especially insurance, like TAL, and or in the US and whatnot. But because I was pretty much just by myself, using a kind of custom built technology, custom built meta models, people were interested in the solution that I had, but they never really bought it per se. And then when I joined NAV a little bit over a year ago, the same problem happened, and the question came: what do we do for our schema architecture? And so we built a project. We made that project open source. It's all out there for you to use. There is we're not trying to sell this. This is not our line of business. And I feel this particular instance of the project is an interesting solution. So I hope I'm going to be able to demonstrate that. So before we start, I wanted to talk about my coworkers, because this is a team project. Even though I kind of started to think about it a long time ago, it wouldn't look like it is today without this team. I mean, this is an exceptional set of engineers. They've done an incredible job to bring the whole project together and integrate it with our microservice architecture. And so this is all the people, Javon, Michelle, Jeff, and Daniel. And Brent is the manager who gave us the resources to work on this project. So without them, this project wouldn't look anywhere close to where it is today. So what is NAV? Just a couple slides to kind of set the stage. I call it a service as a software. I know what SaaS means. That's why I say it's the other SaaS. And what is service as a software is basically a physical service that you expose as a set of APIs. It's not about subscription, cloud, whatever. It's really about, look, there's people somewhere, things, that are happening. And somehow those things we can interact with them via an API. And to do that, of course, well, we have a platform. And I forgot to mention what the service is. It's actually, we're a small business lending platform. We help small businesses apply for loans, get credit cards, monitor their credit. And there's a few things we're about to launch, but I cannot talk about it. It's very exciting. The company is great to work for, great people, great culture. We're hiring, but I really enjoy working at NAV. It's been so far nearly my best professional experience, I would say. So just a couple words on the platform. The core entities that we manage are, leads, applications, and we collect insights. The way, we connect the platform to its environment, we pump data from credit bureaus. We have other feeds that I don't want to talk too much about. Then on kind of the eastbound of the platform, we have the finance partners, credit card lenders, etc. And we also have on the northbound of the platform the partners like Clover's that have a lot of customers. I don't know if you guys are familiar with Clover in Australia. I'm not sure. It's a very big company in the US, but they make point of sales for small businesses, and they have Nav as an app on their platform, and you can push a button to get financing through Nav from their dashboard and different devices. So that's the kind of thing we do. And our physical services, we have lending experts who help small businesses fill out their application and find the right product for them. Our stack is very standard these days. React, GraphQL. I love GraphQL, by the way. When it came out, I felt it was, I misunderstood GraphQL clearly, and I felt it was not a good technology. It's something people should maybe avoid. That was 2016. I completely changed my mind. I love GraphQL. It's one of the most decisive technology in the last 10 years, I think. And it's really enabling microservice architecture at a level that I think would not be possible without GraphQL. I really mean it. This is I got to meet Lee Byron in 2018, and I told him it was extremely well designed. When you look at the meta model, and I don't know if it was accidental. I know they're very smart people, so I don't want to claim it was just an accident, but it's extremely well designed from my perspective. So at the microservice level, we have Golang, Elixir, Ruby, and Python. Why not? If we can be polyglot. As an architect, I would prefer just one, preferably Node.js, but it's not on the list here. Then the back, our database is Postgres, and of course we use Kubernetes. And last year we implemented EventBridge, AWS EventBridge, to add event-driven architecture to our microservice architecture, and that is going well right now. In other words, we were using gRPC for a while, and as you can imagine, RPC type integration is not something very robust. It's very brittle. A lot of little glitches happens, and it's not necessarily a good approach in your microservice architecture. So, any questions so far on Nav or the stack? All right. So when you see a platform like this, you can imagine there's payloads everywhere. And of course, we have GraphQL on the northbound to serve data to our web app, mobile, and also our partners. But we have a pretty complex set of services and growing and interactions with partners, credit bureaus, etc. Here we use Salesforce on the our call center side, and all this requires fairly sophisticated integration and complex payloads. Loan application is not something trivial in some ways. I mean, it's not like, say, insurance policy or claims or things of that nature, but it's still fairly decent type of payload. And validating payload makes your microservice architecture more robust. It's easier to test, it's easier to detect defects and whatnot. And so the idea when I interacted with Brent, who's the director of engineering in the back end, I mentioned to him that project and kind of my ideas around validation. And basically, after a couple months of discussion and understanding what the solution would look like, he gave us the green light and put the resources together to build this project. Because in the past, we didn't have that. There was a little bit of validation here and there, but you can imagine in a polyglot environment like this, it's very hard to keep validation code in sync. It's not necessarily the code that engineers want to write. It's a little bit boring, and therefore this has been an area of the architecture that has not been served well. So the problem is, how do you validate message payloads? And we are transitioning from gRPC to event bridge, so to an event-driven architecture for create, update, delete events. And then, of course, we also have still some more like RPC-like interactions. And that kind of validation code is, as I mentioned, tedious to write. It's hard to keep in sync across languages. You make a change here, another team needs to be notified and make the change and whatnot. So, and if the changes are not happening at the same time, then one side is going to feel this is valid, the other side is going to say it's not valid and whatnot. It's hard to debug precisely because it's across, stacks and languages. And it's hard to maintain when you want to change, add fields, change business rules and whatnot. Again, it's just not a code that people enjoy writing, period. When you'll see what's generated, you'll say, yeah, I could write this, but writing this all day is a problem. As a side note, when I was in Sydney for another project in 2009, it was a short project with a big bank. I won't name the bank. They had a team. It was about between 40 and 50 people writing the equivalent of XML schemas. That's all they were doing. 50 people. And they were planning to grow that team to 120 people. Just for their service-oriented architecture. I don't know if you can imagine 50 engineers that need to be extremely qualified, that their day job, day in and day out, all day, is to write XML schema. I bet with that number of engineers, they had hired pretty much every XML schema expert in Australia. I cannot believe there were, at the time, more than 50 people who were interested. Yeah, I mean, it's not like there couldn't be more. It's just XML schema as a developer is not a technology that you want to learn and start, writing all the XML schema. I don't know a single software engineer who would want a career in XML schema. And yet, this was deemed as necessary. So this is yeah, it was a nightmare. It was, and I killed that nightmare. I explained that this was not possible, to continue like this. And so hopefully they did kill it. But it came to a point where their service-oriented architecture was dying. It was in such a bad situation that anything they were doing would cost so much money. Any change that they didn't know where to go. They had built a $1 billion Australian dollar CRM system for the bank, and the system was collapsing because of this type of errors they had made in the design of their service-oriented architecture. So validation is a pressing problem. It's not a problem you can avoid. And there is not a lot of solutions. Yeah, it's a $1 billion for a CRM system. It was a good one. It propelled the bank to be in the top 4. So it was a well worth investment, very well worth investment. Because it gave the ability to the bank to upsell customers like crazy, and they made a bunch of money out of it. They recovered their money many times over. So the reason why people are sometimes a little bit surprised when you talk about validation is because they feel, well, we have schema languages, so why aren't they working? You know, what's the fundamental reason why people are not using schema languages like they should, you know, to validate payloads? It should be everywhere. We have JSON schema, we have XML schema, we had DTDs before, and none of those schema languages have really taken off. They remain kind of niche here and there, mostly by small, you know, driven by small communities that are extremely committed to make it work, and somehow it doesn't work. And now a lot of schemas have been written. You know, for instance, at the Open Applications Group, OAG, they have lots and lots of schemas. They spend the last 20 years just crafting very nice schemas. But again, it's not necessarily heavily used. And if you go in microservice architectures and, you know, like the modern software engineering shops, very few people are using those technologies. And typically, if you've tried to use, you know, those schema languages, including protobuf, actually, it was funny to discover that even Google couldn't deal with that problem. And the problem is, you can get a sense that the schema architecture that you are currently using is not working when you end up declaring all elements of a payload optional. And this is usually where you end up. You start using a schema, whatever it is, even protobuf, and even Google couldn't figure it out. Google decided to give up and say, we're not going to deal with required and optional. We're going to make everything optional. Can you imagine a company the size of Google run their schema validation with protobuf using optional element for everything? How can you call that validation? And the reality is that there is not a lot of choices. It's just those schema languages have a fundamental flaw, and they cannot, you cannot, yes, please, go ahead.
Okay, I'm really curious. What do you think the root cause is? Why is schema not working?
I will explain it in the next slide. So it's because they're flawed. Their design is not is broken. It's as simple as that. And so I'm going to try to explain it. So the problem that XML schema cannot deal with is to create reusable data types that you can use in different payloads. And there's been attempts to do that. You may never have heard of those patterns, the salami pattern, the Russian doll pattern, or the Venetian blind pattern. But basically what they're trying to do is to create a type, say like customer, and they slice it into different things, you know, the name, the address, the city, the zip code, etc. And then they say, all right, in a payload, when the customer entity is present in that payload, you're not going to have all the attributes of the customer in the payload. That's not how it works. You're going to have a subset. And because we slice the customer entity into those little types, those micro types, now you can reuse them however you want. And that doesn't work really well. It's very tedious. It's not a good approach, in my opinion. And some people have spent years of their careers on trying to make this work, but I don't think it is. And here's the problem with schema languages. This is where I think the flaw is you can specify a data model with a schema language, no problem. You can take an entity relationship data model, and you can create a schema that will express that entity relationship diagram pretty well. You can, of course, use a schema language to define the schema of a message payload. No question there, of course. JSON schema, XML schema, all this works. The problem is you cannot do both at the same time. And when you create a schema architecture, you need both. You're not going to create individual payload. That's what this bank was doing with those 50 people. They had to create individual payload and maintain them, forever. Each time there were some changes and sometimes ripples across, so many schemas. Then this is the problem. And none of the schema language designers have really addressed that problem. They've not identified the problem, and therefore they've never addressed it. Because for them, yeah, go ahead.
Can I don't want to interrupt you, but I'd like to suggest a reason for that. It's actually very, but I don't want to interrupt you. Can I do it now?
For me, the reason is because they focus on only one problem, which was specifying message payloads validation. They never look further. They never try to expand the scope and say, all right, people don't express message payload validation rules in a vacuum. They express it in an entire information system, but they never look at it that way. Now, go ahead. Let me know what you think.
I tell you what I see, and I may be wrong, of course, but I think that the notion of messaging is very different to the notion of data model. And the reason for that is that messaging is actually a thing that happens between two, a sender and a receiver. And those senders and receivers may be different organizations. They may be living in different mindsets. They may actually be working with different data models. They may have different perspectives on how to look at reality in the extreme. And that is actually one of the reasons semantic technologies were built early on in order to integrate disparate data schemas in the internet, where data schemas are representation of source data over which you have no control because it's on the internet. And yet you do want to integrate them somehow in graph databases or things like that. So that's what I was thinking about. Don't know if this is really true in reality or to what extent, but that would occur to me. So the solution is an integration, interoperability integration feature.
So for me, that's really the fundamental problem is that you cannot specify both at the same time, specify data models and message payloads. And if we want to, kind of look at it graphically, this is what it would look like. You have your data model up here with, customer entity, orders, shipment, whatever. And then you have your messages, and your messages are basically a mashup of, data elements from different entities. And I call that mashup a projection. So, and there is no schema language that is able to express that projection. And until you have the ability to express that projection, then you cannot create a data model that is used where the entity definitions are used to define message payloads. And if you can do that, you're going to define individual message payloads, and it's going to be harder to maintain and whatnot. It's going to take a lot more time, and that's why people tend to not really be interested in those technologies, whether it's XML schema, JSON schema. Protobuf is a little bit better because you have all the code generation, and it's kind of a given if you want to use gRPC. But I'm not sure people really enjoy Protobuf as a schema language per se. So how does the solution look like? Well, you need two domain-specific languages, an enterprise data model, DSL, and a message type DSL. And the message type DSL need to be able to reference the entities of the enterprise data model. And then from there, you can create message type definition and you can create an enterprise data model. And once you have that, you can generate, JSON schema, Golang, Python, Ruby, Protobuf, any language you want, pretty much. So when I revisited the problem for Nav, about a year ago, I realized, geez, if you look at GraphQL, what is GraphQL? It has two DSL. It has an enterprise data model DSL to express, entities, and it has a query DSL. And if you look carefully, the query DSL allows you to express the content of messages. And those messages are defined, the message structure are defined in relation to the enterprise data model that you define in GraphQL schema. So bingo, finally, there is actually a popular, let's call it DSL to start with, that you can use as a schema language. And that has not happened, as far as I know, up until now. And, GraphQL is not only popular, but it has a developer experience that is, probably one of the best in the industry, with editors, viewers, parsers, the mindshare, how many developers have learned, enjoy using GraphQL. It's pretty, I think, it's something that is hard to dispute. It's like GraphQL is a very popular technology, easy to learn, easy to use. And the more we can use it, I would say the better. And so what I'm suggesting here with this project is that not only you can use GraphQL with the runtime and as it has been intended, but you can now use GraphQL DSLs for other uses. And I'm just suggesting one. I'm pretty sure there are others that could be just as interesting. But that one, I hope, is also solving an important problem in microservice architecture. So how does it work? Very simple. You define your data model with GraphQL schema. You define your message structure with GraphQL queries. And you use the project that we created, and voila, you get clean code, clean validation code in different languages, such as Golang. And that code, almost any software engineer would be able to write it. But at scale, if you have dozens of message types, if those message type contains dozens of elements, that code starts to look just too much. And you can easily generate thousands and thousands of lines of code from very little GraphQL. So let me go to the project now. So all the references are in the presentation. I will share the slides later on. And this is the project. So again, it's open source. It's on GitHub. It's designed for our use. We created generators for our languages. However, creating a generator takes about 250 lines of JavaScript. It's very easy to write. The whole harness, the whole generation harness doesn't need to be touched pretty much. I don't think you would need to. Let's say you want to add another language, I don't know, Java, for instance. I believe that can be done in a couple of days at the most, and still discovering the whole framework. And of course, if you ever do that, feel free to, bring it back to the project. I think the more generators there are, the more interesting the project will become. And we don't use Java, so we don't have a huge incentive to recruit people to augment the project. It's not going to help us per se, but personally, I believe this is an important project. It's something that can really solve key issues in a microservice architecture. So let me show you the content of the project. Let's start with the generators so that you get a sense for what they look like. Let's take a look, for instance, at the Python generator. So the whole project is running in Node. And what does a generator look like? It has a few methods. So the first step, probably the thing that is least intuitive is that the message type is a type that doesn't exist in the enterprise data model by definition. The enterprise data model will contain entities like customer, purchase order, invoice, etc. And a projection will be a message type, and therefore that type doesn't exist. So the first part of the generator is to actually recreate that type from the parser of the query. And this is where you kind of bootstrap your validation. So you have your imports and whatnot. And then from that point, there is just a couple method, let's see, that generates types. Let's see, validation rules. Here, the struct def is the one that generate the type. So you could see like a Python class, for instance, right here. And we generate validation rules. It's another method. All those are JavaScript template literals, so they're pretty easy to write and understand. There is not a lot of issue with that. And as you can see, the Python generator right here is the longest, and it's about 370 lines of code. The Go generator is a little bit more compact. It's about 250 lines of code or so. So, and they look pretty much all the same. So you can use one as an example, and all the parsing of the metadata is done for you. All the metadata is available via function calls, etc. So it's very easy to write those code generators should you need other languages. There are quite a bit of details around specific languages that I will not have time to speak about right now. But if you have any question, if it's a project you want to use, feel free to contact me, and I'll see if I can answer some of your questions. The parser is based on GraphQL tools, and I just created wrappers because GraphQL tools parser is not very easy to use. So I created some wrapper to get different things like the type of something, the value, the arguments, the directives. If you're familiar with GraphQL, all those wrapper functions will be just as familiar to you. They're not something very specific to this project. They're just a more convenient way to access metadata that is parsed by the GraphQL parser. And then there's just a little bit of utility function, nothing out of the ordinary, something you would find you would have written just as well. So so the key of the project is, of course, how you define the metadata. So as I mentioned, we use GraphQL schema to define the enterprise data model, the entities. So here, we're not using our data model. We just replaced it by the Twitter equivalent data model with the notion of users, tweets, nothing surprising. And the way you connect the enterprise data model with the messages is via the queries. So it's a little bit of a hack. It probably could have been done better by renaming the query type to something else like message, but it's really a detail. It would not change anything if we were not using queries, because here it's not like say Reusable or Swagger. We're not defining the operation. We're just defining the message payloads because we're interested in creating and generating libraries of validation code for all those payloads. So, obviously those are not queries, but they're just a marker for us to say, all right, there's a message called my tweets, and it starts with a user type. And from there, using a GraphQL query, you can define the content of that message. So let's look at the profile message, which is right here. And the profile message is a user. So here's the user. And as you can see, this is a projection of the user. So we are free to use a subset, of course. And the rules and the types that are defined in the common data model are reused in the code generation. So when I define the message structure here with the query, I don't have to specify that the ID property the ID field is a UUID. It's inherited directly from the data model. So that saves a lot of time. Once you invested in your data model, now defining message types become very trivial, extremely simple. So you probably already have noted there's this pesky property called order. This is only if you want to use protobuf, because protobuf requires an order to be added as you generate. Yep. You should interrupt me. You don't have. Yes, of course, absolutely. So you can also extend the project by adding directives if you want to capture other types of metadata that is not captured in this project, and you want to use in the code generation. The project itself is pretty much usable as is. You would need maybe to generate your own language if you're not using the one that we have implemented. Say like Java, you need to create a Java generator. That's a pretty simple task. But everything else is pretty much usable as is. You don't have a lot of work to do to use this project. But you might have something very specific for your environment that you want to capture in the message payload, and then you would add directives for that, and that metadata is easy to get back in the code generator through the parser and the wrapper function that I've written. One thing that is important is you can actually override some validation rules. So for instance, here the ID is required, or let's say the email. So email here is not required, okay? But you can override it and say in this particular payload, it will be valid if and only if it has an email. If it doesn't, then it's an invalid payload. So those are the kind of this is the kind of expressivity that you can have that is a little bit harder to have in a traditional schema language. And in any case, in a traditional schema language, you will never find a way to connect an enterprise data model definition to a message payload. You will have to define your message payload individually, pretty much from scratch, as standalone. And there are benefits to use standalone schema definitions, so like json-schema. I like standalone, but from a definition perspective, standalone is just too tedious. You will very quickly draw in the amount of metadata needed to define standalone message formats. So that's why people have tried to define ways to reuse information in an XML schema, but again, they've not been successful. So invalid messages, then it becomes your call, right? You know what the call, what the generated code does, it just tells you this message is invalid. After that, you know, it becomes your call. You know, we're not prescriptive on what happens then. So basically, if you look at the, I'm not sure what this is. It looks, this shouldn't be here. Okay, so if you look at the code that is generated, you know, we have all those validated methods and whatnot. It's kind of cascading over the message structure. And all we tell you is that this message is valid or not, nothing else. You know, we don't want to be prescriptive as to what happens if it's invalid. We just give you a piece of code where you give us the payload, say JSON, and we return it's valid or invalid. And the idea is, in a microservice architecture, you probably want to validate as you send a message and as you receive a message, so that you have kind of this safety that says both sides agree on, you know, how they communicate. Because the more glitches you'll have, the more very subtle bugs will happen, and they may happen in only a certain number of cases, and even a very small number of cases, because the data that you're carrying now in the payload, it just has this little glitch, this little property that makes it invalid. So that's how, you know, how we see it. The other thing that I didn't mention is, you know, say like just like Swagger or JSON schema, we use in GraphQL scalars to define regular expression. So as you can see here, we've defined a number of scalars. So again, they're not, there's no runtime, there's no GraphQL runtime in this project. It's only metadata. And if you look at a scalar definition, say in Golang, so you will need to define what the scalar look like in Golang, you know, in every language. You will have a regular expression for each of the scalars. There is a few other things that you can do, but mostly it will be a regular expression. So I'm wondering if my PC is not overloaded right now. So that's probably the reason why it was. So anyway, that's in a nutshell, this is what the schema architecture is. So GraphQL schema for expressing the common types, GraphQL queries for expressing the message structures. We can define scalars for, you know, using regular expression to validate some data element content, and then we generate the code in as many target languages as you want to validate the different payloads. It's very simple. There is really not much to it. I created the proof of concept in a weekend. It was a snowy weekend last year, and we couldn't go anywhere, and so I just started to bang at my keyboard. I showed that to Brent, the director of engineering, and you know, after a few weeks of back and forth, we decided that it was a good idea for Nav to complete that project, and here it is. You know, it's not a big project, but I think it can bring quite a bit of value to a microservice architecture, and it's using GraphQL, so it can't be bad. Okay. Any question on what you've seen, or?
If anyone's got any questions, feel free to unmute yourself and if possible, turn your camera on.
Yeah, maybe I'll jump in again. I have a question actually. I imagine that the payload is actually untyped, meaning there is no tag information in the payload what type of data actually is being sent. In that sense, for example, you know, I was thinking about of all languages, Ada, a very strongly typed language, and then Python, an untyped language. So in Ada, a valid payload for a certain integer that is constrained to be between 16 and 28 would define its validity as a type. Over here, you would probably need to describe that differently. I'm not sure whether a regular expression can do that. So the question is, that's maybe another step where you can actually define types.
Correct. I'm trying to find an example because, yeah, you see that we in Python we had to add things like instantiate. We had to add semantics because it was not, you know, let's say a date was not a regular expression, or so we had to add some concepts, and the way we're thinking about it is to extend the concept of scalars such that the code generator would get either snippets, you know, like this, or anything you can inject in the code generation. My understanding is that it should be done at the scalar level, at the scalar definition level. That's how I see it. I cannot say we have like thought of all the possible cases. We have thought of cases that, you know, are reasonable for us within our scope. I agree with you that this needs to be extended at some point, but so far we've not felt really the need to do so. We've been able to deal with it with what you've seen. But it's easily extensible because you see instantiate in a Python scalar definition. It has no meaning in other, you know, in other languages. So you will not find the same thing.
Great, thank you. It's a beautiful infrastructure. Thanks.
So yeah, thank you. So I had a conclusion slide. I just wanted to reiterate that, you know, managing payload validation is a complex problem, and you cannot approach it lightly. It's if you approach it very linearly and say, oh, I'm just going to keep building schema definitions, very quickly you'll hit a wall, and it's not going to end well. Clearly, I mean, it's not something that you can just take casually. You could say, well, therefore, I'm not going to validate my payload. That's another approach. That's probably not going to end well as well. You know, you're probably going to spend a lot more effort than if you had a simpler solution to define payload validation schemas. So here, you know, the idea is you have a tool that allows you to reason in terms of contract first. And in my opinion, after spending 20 years building service-oriented architectures, almost 25 years now, contract first is really the best approach. It's, you know, code first, or, you know, not being clear on the contract of your interface is not necessarily a good thing. Yeah, some developers are so smart they can figure out everything on the fly. At the scale of a company with lots of teams working together, I don't believe that that's a good value proposition to rely on extremely smart developers to fix that problem for you. The other thing is that the enterprise data model quickly becomes a key asset. It's something that helps teams communicate with each other, because now they can see the data model, the logical data model, independent of databases, because you have other details there that are not necessarily relevant for message passing. And in my opinion, it also helps data governance. So when you start changing your system of records, you start adding fields to your databases, you can have a very quick analysis on what it means at the message level, where things are going to surface in different message type. And it becomes very easy to modify because, again, GraphQL is very easy to use and great tools. The mail model is very easy to understand, but pretty much anyone in your organization, unlike schema languages or writing complex validation code. So in our case, this project has been running in production for the past 4 months. We so far we don't have any complaints about it. It's working as expected. It's doing its job, and hopefully we've avoided quite a bit of aggravation by making sure at deployment time, by testing that our communication is robust, and what is expected, what is being pushed from one side is expected on the other side. So that's pretty much what I had. It was a quick introduction. Hopefully you found it interesting. And any other questions? Or
does anyone have any other questions for JJ? If so, feel free to unmute yourself and, if possible, turn on your camera.
Yeah, I had a couple of questions. Thanks, JJ. Very interesting. One sort of low-level thing, which maybe I missed, but for you had some code in there that had required for the I think that was it generating protobuf, and I missed how you specified whether certain fields were going to be required or not, or how it knows to put the ordering in. Oh, I guess it can figure that out because everything has an order. But how does it know that ID, username, and email are required in this case?
So protobuf, my understanding is that it's. I'm not a specialist of protobuf or Golang, so that my understanding is limited. I just noticed that when they moved from V2 to V3, they abandoned the required versus optional, and they made everything optional. And now they kind of coming back and say, maybe we need required in some cases. So I am not 100% sure how this is generated in protobuf, because again, I'm not a specialist. So let's see, profile. This is what it looks like. Yeah, there is no, we ignore the required field in the current generation. And again, my understanding is in V2 of protobuf, Google had a required field, so it could be optional or required. And in V3, they made everything optional because they clearly said they couldn't handle, they couldn't deal with it. So that's weird, I mean, a company that size with so many exceptional people, they can't solve that problem. It's weird. but it just tells you the intensity of the problem, and why in XML schema or JSON schema or Swagger, those things are not dealt with as well, because it's a hard problem to crack. And this is not cracking the problem, it's coming from a completely different angle and say, hey, look, you can't deal with it with a single DSL, you need two. And if you use two DSLs, then the problem is not as complex. You don't need super smart people. People like me can figure out the solution. So that's kind of where I see the difference between people completely focus on the problem is just, we're going to validate payload, and they never look at the bigger context is how do we validate payload at scale? We now have hundreds of payloads we need to validate. Is the solution that we provided for one payload, is it going to scale to hundreds or maybe even thousands? And once you ask the question that way, then you have to find another solution.
Yeah, interesting. Forgive me. The actual premise of my question was actually false. I thought there was the previous file that you had open there. I thought that was a protobuf file, but it was actually the other. It was actually the GraphQL file. So the required is a directive in your schema.
Correct.
You're telling it whether it's required or not, and then a particular backend protobuf or a language one decides what it wants to do with those things. Yeah, so yeah, that's making more sense now. But when I looked at it, was watching it while you were talking earlier, I mistakenly thought that was protobuf. So yeah, makes a lot of sense now.
Good. Yeah, and the idea is you can add easily directives to express other things. If they're relevant to your organization, you think about business rules that we've not implemented, you can add those directives. Just like Danielle was saying, if the value is to be between 16 and 28, you could add directives. It wouldn't be that pretty. It wouldn't be something like a nice syntax, because you cannot expand the syntax of GraphQL, but you could still do it. You wouldn't be limited. You could easily add directives that allow you to do that. Like you could add a range directive, for instance. You could say at range, and then you could say 1628. This is totally doable, totally supported by GraphQL, the parser of GraphQL, and therefore you get that metadata and you can generate your code using that directive. So there is very little work to do this kind of thing on top of this project. It's just, our goal was not to make a product. We're not trying to sell this. We're just offering it as a seed. If other people feel they want to expand and complement the project in those directions, that would make us happy. That would make me happy. But we don't have the resources to make it a product. It's not our goal. But I really want to emphasize we use it as is. It's not something that's a toy, or it's used in production everywhere in our microservice architecture. I also wanted to emphasize the work done by Michal Sainsky, one of the engineers on our project, because one problem of generating code and checking it in GitHub so that it becomes available to other projects is that it took us a lot of time to build a build pipeline to do that. Naively, I tried a few things, didn't work, and then we continued, and Michael cracked the problem. And if you ever generate code, even outside this project, forget schemas and whatever, if you ever write a code generator and you face the same problem where you need to check the code back in the project, and that's the output directory here. Michael has created an architecture for that, for the build pipeline. And it works in GitLab, so it's not a GitHub implementation, but this is remarkable. It took him a while. He's one of our best engineers, and it took him a while to come up with it, but it's truly remarkable. And I'm expecting maybe once people who build code generators projects discover that, they probably will borrow it. I wouldn't be surprised if that build pipeline has a life of its own outside this project.
All right, cool.
Sorry, I did have one more question, if that's okay, Paul.
Yeah, for sure. Go for it.
Yeah, another thing I wasn't quite clear about, the code that you're generating, can you use that to generate clients and servers, or is it just clients or just servers?
So it's a validation library, right? So you can use it both on the client and the server. So we use it on both sides, because we want to, especially when we publish events and we consume events, we want to make sure that there's no glitch, because the code has been written by two different teams and different times, etc. We want to make sure that this communication is robust. That's really the origin of that project. So the code itself is really designed to run on both sides.